I was thinking about this talk earlier today and kind of looking over the various other presentations we have here this week. I'm going to kind of shift my emphasis a bit, and I'm going to try to do this in more of a historical context of like, how did we get to this point? And then talk about how these parts all kind of fit together and what that looks like. I'm amazed at how often I'll talk to somebody and we think we all understand what these terms mean, and then you start having a conversation and realize, oh, no, I didn't realize that's what it meant. My boss, Andrew Clay Schaefer, has this great tweet that I use all the time, and it's who wants to argue with me about the definition of made up words? And that's this huge part of our industry is we make up these terms, or we steal them from other industries and then give them a completely different meaning, and then we just assume everybody knows what we mean by that, and generally not so much. So with that in mind, I'm going to kind of change the emphasis a bit as we go along. This cloud thing is pretty amorphous for a lot of us. There's a lot of different options that we can easily put under the banner of the cloud. I talk to some people and the first thing that pops into their mind is, well, microservices, of course. We've got to do microservices. And other people are like, no, we tried that and it hurt. And so now we're really focusing on modular monoliths. And I work with some customers and it's all containers all the time. And of course now I can't seem to swing a dry erase marker without somebody saying it's all about serverless. It's all about functions. And of course, these days, I'm quite confident you can literally put as a service at the end of anything, and it's a thing. I actually had somebody tell me once that I'm an architect as a service. And I thought for a second, hey, that's really cool, but then I sounded out the acronym. And I was like, ooh, wait, that might not have been a compliment. So we understand that that's kind of the in thing, right? It's like serverless functions, this is the cool thing to do, and we all want to be doing the cool thing. And then a few of us will look around going, but wait a second, I just refactored my legacy code or heritage code, if we want to be more positive, to these cloud native microservices, and that just makes me grumpy. I don't want to be like that. Now maybe you're old school and you prefer this one. I actually used this quite a bit this week because I've had some interesting experiences with the TSA agents, and I'll get into that at a different time. My wife actually saw this slide and she looked at me and she says, what the heck is that? I said, it's table flip. She said, table flip? I said, yeah, can't you see? Arms are up in the air, table's upside down, table flip. I literally have a text expander for this. So she didn't quite understand. She just kind of shook her head and walked away. I think that was a positive thing, I'm not sure. So please don't throw away that code quite yet. We can actually leverage a lot of that. And quite honestly, the real takeaway I want you to have with this session here today is all of these things are tools. All right, and I'll talk about this as we wrap up, but this is really what I want you to think about is these are just different tools that we can bring into a situation. And what the onus on us is really trying to understand when should I reach for which tool. That's really what separates the complete novice from someone who has that experience, who's in the journeyman master part of the stage. So I want to go back in time a little bit. I want to talk about IaaS, because that's where a lot of this stuff started. And let's be honest, infrastructure has really changed over the course of my career. I've seen this just massive, massive shift, and I'm sure many of you can relate to this. I've done this long enough now that I very distinctly remember when servers were this homegrown artifact. They were bespoke, they were artisanal. And while we really appreciate that, maybe in like a sandwich, probably not what we want in our infrastructure. And if I think back long enough, I still remember when you would like order the parts and you would hand assemble this server, again, it was this bespoke artisanal thing. And it could literally take weeks, months to get a new server instance. So this is always a fun party game at a conference like this. What was the longest request to ready experience of your life? So you needed some hardware spun up, you put in the request, I'm sure everybody in the room can go longer than a month. Anybody go longer than 3 months? How about longer than 6? Anybody go longer than 9 months? Okay. I waited a year once for a development database. That one still I'm still scratching my head. I'm like, we need a development database, and a small one, it wasn't even that large. And it took a year from request to, oh, hey, we have that database available for you. It's like, how is this possible? I don't understand. Did you write the database? What's going on here? Now, the really dangerous part of this is it forced us to make a whole set of decisions incredibly early in the process when we knew the least. So a classic question that we'd find ourselves trying to answer early in a project is, hey, how much capacity are you going to need? And the only answer we could legitimately give is, I don't know. Because I don't know yet. I mean, when you ask me in the first couple of months of a project, we really have no idea what this thing's even going to be yet. And so what most of us would do is we'd take the worst possible case, we would double it, we'd add some buffer, and then maybe add a little more, just because. And that was the rational thing to do. Because in most organizations, it was a 6-week lead time, which, by the way, weeks in most IT organizations translates to months. Right? I learned this, I knew this, but I was refreshed on this last week. I was talking to someone from Norway, and I made the comment that my house is about 20 miles north of where you were. And they're like, oh God, that's what, like a 2 or 3 hour drive? And I'm like, wow, what kind of traffic do you experience? And then she said, oh, I'm sorry, that's right, in Norway or Sweden, I can't remember which one it is, a mile is like 10 kilometers. I'm like, oh, no, we really just mean a mile, so like a couple kilometers. Like, oh, okay, yeah, that makes a lot more sense. So that to me is that exact equivalent, right? You know, we say weeks, we really mean months in so many cases. And of course, my experience with enterprise IT is that meant lots and lots of tickets, and that meant that I had to go to lots and lots of meetings, and I had to fill out lots and lots of emails, and then more tickets, and then more meetings, and more follow-up, and eventually I would finally have a server. And so we'd give them pithy names. I worked at one company where our servers were named after Simpsons characters. That was always kind of cute and fun. And let's be honest, we treated these things like pets. When they got sick, we spent whatever it took to get them healthy. You know, so we treated them, well, frankly, like I treat my cats. All right, this is Han and Chewie. You can probably figure out which one's which. And I'm quite confident that were either of my kittens to come down with any kind of malady, my family would strongly urge me to spend whatever it took to make them healthy again. And frankly, that's how we used to treat our infrastructure. Do whatever it takes, spend whatever it takes. And the rationale there made sense because these were a very expensive, very heavily constrained resource. We spent a lot of money on them, and so we needed to get our money's worth out of it. And so it was around this time that we started building app servers. Because we realized if I'm just putting one app on this very expensive server, I don't get much of a return on investment there. It would be so much better if I could put lots and lots of apps on that server and thus maximize that return on investment, which makes our CFO very happy. Now, of course, there are some unintended side effects of that approach. We now have shared resources, which means, of course, your bug takes down my app, which means coordinating changes hurts. I mean, how many times have you had that experience? Like, I'd really like to move to this version of Java or this version of this framework. I need to update this. I want this DLL. And you're like, I'm sorry, you can't have that until everybody else is ready. This is why we can't have nice things. I remember I had an application, this was probably 4 or 5 years ago, and we very much wanted to be on the new strategic single sign-on solution. And so I talked to my security folks. I'm like, when's that going to be available? And they said, oh, it'll be available in June. I went, fantastic. We're going to try to go to production in like May. This looks like this lines up really well. Outstanding. And so, you know, I factored into the whole equation. We'll have a tactical solution in there for a little while, but that's okay. So a couple months later, I'm meeting with my security folks again. I'm like, hey, are we still on pace for that? Like, yep, no problem. Oh, but by the way, you need to get at the head of the new server upgrade list. So make sure all your servers are upgraded to the latest version of whatever. I'm like, okay. So I talked to the guy in charge of that. He puts me at the head of the list. And so all my servers get upgraded. And I go back to security. I say, hey, this is fantastic. All my servers are ready. So I can have the new single sign-on solution, right? Well, one little problem. They won't change any of the images that we're using until all of the servers have been upgraded. Like, so when can I have the single sign-on solution? Oh, don't worry, it'll be June of next year. I'm like, oh great, so I'm gonna be on this tactical security solution for not the month or two I was expecting, but more like 16 months. That's fantastic, outstanding. And this is why so many of us had these wonderful experiences with currency, where we'd have this 18-month period of, I'm sorry, business person, you can't have anything new. We're gonna freeze everything the way it is. We're going to do lots of testing, lots of regression. It's not going to be much fun, which is, of course, why most organizations said, no, we don't want to deal with this. This is not getting me any new features. And so the fascinating part of this is it leads to one of my favorite Yoda quotes. Fear is the path to the dark side. Fear leads to anger. Anger leads to hate. Hate leads to suffering. Or as I like to refer to it, Yoda ops. And so, of course, in this era, what we were also doing is moving code from one instance of an app server sitting on one piece of hardware to a completely different instance of ostensibly the same app server on yet another piece of hardware, which led to the infamous, it worked in dev, but not in test. One of my friends actually had stickers made up, works on my box. And if you ever uttered that phrase, he would slap that sticker on your laptop, and it was not a badge of honor. This was no fun. You stare at these environments and you're like, but the environments are the same. How can it work here and not work there? I had one particular experience. We spent, I don't know how many weeks trying to figure out what was different between these two environments, and we finally figured out the only difference was the order the patches were applied. You just realize, my God, what have I been doing with my career? Is it too late for me to get into some other line of work? You know, I'm thinking like, does this happen in other industries? I don't know. I mean, this is the only one I truly know. But we started to see this shift. I mean, if you look at the way we approach things today, our servers are commodities. Instead of this proprietary hardware, proprietary software, we're using Linux, we're using Intel chips, and so we've got this much different approach. It's a commodity. Not surprisingly, prices dropped. And we looked around our environments and went, hey, the server's not really our constraining resource anymore. It turns out it's us. We actually trump the hardware cost in so many situations. And so out of this grew things like Heroku, AWS, App Engine, Cloud Foundry, Azure, et cetera. And it's at this point that we started to realize, wow, shared servers are actually a liability. I don't want to be on the same server as somebody else. That's going to be a problem. And so we start to treat these things like cattle. If one gets sick, we just replace it. You know, so if you've ever been to a large cattle farm, you realize they don't name the cows, they give them numbers. And so if 15 gets ill, we don't necessarily want to spend the time and effort and energy to make 15 better. We'll just put 15 down and get a new 15. Rinse, repeat. Now, that's not entirely true. I actually grew up on a hobby farm, and we had a couple dozen cows, and we did give them names, although admittedly some of them were reminders of what was going to happen in the fall. You know, so it was not uncommon for a cow to be referred to as like hamburger. Or I know it's a little macabre, but you know, you learn interesting things growing up on a hobby farm. We actually did have one cow, we called her Houdini, because she knew how to get in and out of the pens at will. She never went very far, because she's like, Mom's in there, so I'm not going anywhere. But the first time that we realized she could do this, I was sitting in our living room, and you know, you kind of feel that presence, like there's somebody watching me. And so I look over my shoulder, and here's this 300-pound calf standing on my back deck, just staring at me, like, hey, what's going on? So she was literally just like this big, you know, 800-pound cow as she grew, or dog as she grew up. You know, she'd walk up to you and kind of nuzzle you and scratch her behind the ears, and she'd moo at you. But that's the exception. So we started to introduce a lot more automation here. We brought in things like Chef and Puppet, infrastructure as code, and that makes a lot of sense because let's be honest, as much as we like this artisanal thing when it comes to our sandwich, the reality is people just can't do the same thing twice. If you don't believe me, go try to play golf. All right, I love golf, but you know, it's just so obvious that you can't actually repeat in that sport with any great deal of consistency. And that's fine for a hobby, for a sport, for something that we do for fun. Not so much when it comes to software. We'd really like some consistency here. And so the reality is a script will do the exact same thing every single time. And so unsurprisingly, as we shifted away from this bespoke hardware to this infrastructure as code, lead times dropped. And in fairness, a lot of this was a reaction to what many of us were doing with public cloud providers. Not uncommon to see an organization spin up what amounts to a shadow ops group. I've seen this quite a bit. A team looks around and says, hey, your lead times are too long. Turns out I can get something spun up on a public cloud provider in a few minutes using nothing but a credit card, so why should I wait weeks or months for you? We're just gonna go do this on our own because it's faster. And so for many of us, the whole purpose of IaaS was, hey, look, now I can provision these resources very, very quickly. And of course, often this means on-prem. This sometimes meant self-serve, sometimes not, it just depends. I know the first experience I really had with IaaS, it was honestly just the same thing as before, but faster. And so how did we start to provide that? Well, virtualization, that's at the core of this, which is just yet another abstraction over that physical resource. You know, you've got a hypervisor managing all your VMs, and now you get these coarser-grained components. Now, as much as we've moved away from IaaS, it's still very useful There are still times in our career where it's like, I just need that level of control that IaaS gives me. I need to know the ports and I need to do specific things. That's just the nature of the beast. But the flip side of that is it's so much more for us to manage. And we always need to think when we do something like that, hey, with great power comes great responsibility. And so while yes, I have all this control, I can do anything I need with it, I can install whatever I want, I'm now responsible for that. There is a long-term care and feeding arrangement that comes along with it. Now again, there are instances, even today, where I still need that level of flexibility, but in general, that should not be the first thing we reach for. Now that said, it's still the fundamental underlying layer of what we mean when we say cloud. That's still what's there. Now on top of that abstraction, we started using containers. And for most of us, containers is synonymous with Docker. Doesn't have to be, but that's close enough for government work. Now, a lot of people are like, Docker is this magical thing. I've noticed in our industry, and I've seen this with almost every technology, I'm not picking on Docker here at all. A new technology comes out and you'll talk to someone and it's like, we need to use that technology. And you say, great, why? And they repeat the name to you. We need to use Docker. Well, that's cool, why should we use Docker? Well, because Docker. Okay, I think we need to go a little deeper than that. And there's a lot of confusion. What do we mean by Docker? Well, in its core, it's just a box. That's all we're talking about here. I mean, the best analogy is the shipping container. If you think about what shipping used to be, it was a very manually intensive process. You needed lots and lots of able-bodied people to carry things on and off a ship. Now, the beauty of that is everything could just be, hand moved and, you could plinko it all together, but it was not a very efficient process. Unless you were responsible for the Longshoremen's Union, I guess. Along comes the shipping container. Now we have this commoditized box. They're all the same size. You put whatever you want in the box, and then we pick the box up with a crane, put it on a ship, gets to the other spot, we take it off the ship with a crane and drop it literally on the back of a semi-trailer and away it goes. Works out really, really well. You can put whatever you want in it. Although I have to admit, if you've ever seen those pictures of those container ships, how high they're stacked, you just think, how does that not just topple over? I managed to do some whale watching recently, and it's amazing how powerful even like 4-foot waves are when you're on a small boat. And you realize, like, if we're getting tossed around, what happens on the open ocean with these container ships sliding back and forth? So the analogy for us here is that we put whatever we want in the box, including everything our application needs to run. And so you put your code, you put your libraries, you put your executables, configuration, et cetera. And so now everything is in that box. And I'm completely isolated from any environmental differences. So let's be honest, we sit here and we go, hey, how often does my staging server actually match my production server? Well, hopefully, but not always. And so instead of being in this model of I'm going to copy code from one environment to another, from one instance of an app server to another, here's everything I need. That's the abstraction I want you to move. And in many cases, we don't even move it at all, we just change a routing table. So conceptually, that's not that different from virtual machines. It's just a matter of where are we doing the virtualization. So is it at the OS level or the hardware level? Now, the flip side of this environment is, of course, you've got to tell Docker everything you need. So that's typically done with a Docker image, which you can store in a registry, perhaps Docker Hub looks something like this. Isn't that amazing? So that happens to be the community-driven portion, which means it's not vetted, it's not curated, anyone can push anything, anyone can pull anything, so please don't pull down someone's turn my computer into part of your botnet. Now, of course, there is a vetted portion, that's the Docker store, which is exactly what you think. It allows people to sell you images. Isn't that nifty? So you can go there, you can do a search, imagine that, and sure enough, all sorts of cool things will show up. And you can say, hey, what's Sun, or not Sun, that's how old I am, what's Oracle got? Now, of course, this is vetted content, this is curated content, this often comes from a commercial entity. These are things that are typically approved by Docker. And many of these images are, in fact, supported by those particular entities, and there may or may not be a cost associated with it. There may be a licensing thing that goes along with it. And of course, some of these might be certified. And of course, some of these images that some of you have probably used actually come directly from Docker itself. In fact, I just did a search for Java and you find out there's a whole bunch of different things. Now, whether or not those are still useful to you today, maybe, maybe not, depending on what you're doing. But under the core, all we're talking about here is a registry. And so you take a step back and you ask yourself, well, hang on, what the heck do you mean by image? What's an image all about? Is this a picture? Kind of. You can think about it as a template, you can think about it as a recipe for how do we build that thing. Now, in many cases, we are customizing an existing image. We're taking something that someone else has built. You can think of this sort of as an inheritance role if you want to look at it that way. And so that parent image acts as a starting point, and then we customize to our heart's content. Now, that works really well, but keep in mind, you are responsible for everything that goes in the box. You are responsible for updating that. You are responsible for maintenance. I'll say it again. With great power comes great responsibility. Now, one of the things that I try to emphasize when I talk to people is that we as software professionals, we have this focus on what's new, what's hot, what's interesting, and we always have to take a step back and remember that currency matters. This is finally starting to bubble up to the C-level folks. Every CEO, CFO, CIO is very familiar with Equifax. Many of them have probably also heard of Exactus. We're starting to understand that these are major, major events. When Target got hacked, high-level people lost their jobs. And so we're starting to see this emphasis on, hey, we really do need to care a bit about this currency thing, even though it means I might not get something new for a while. That's okay. I just don't want to be the next largest hack ever. Yeah, and we're starting to see really interesting bugs start to show up that are, in some cases, very difficult for us to easily fix. And so you start to realize that there's a lot that goes into this. I remember a few years ago, maybe it's longer than that now, there was a bug in comments collection. And it was fairly trivial for us to figure out what apps had it. But then you got to work with all the apps to figure out when they can upgrade. But then you also got to realize, well, when are my app servers going to upgrade? It's an interesting problem to deal with. We're like, what is our vulnerability? How long are we going to be vulnerable? Now, of course, in today's world, if I talk about Docker, if I talk about containers, the next thing that usually comes up in private conversation is Kubernetes. All right, so K8s is just a way to deploy, scale, and manage containers. This comes out of work done at Google. And as I like to say, this isn't their first rodeo. They know what they're doing. They have a tremendous amount of experience in that space. So as you can expect, a lot of the features that we would expect to be there are, so self-healing, scaling, service discovery, load balancing, how do I automate rollouts, rollbacks, all that kind of fun stuff. So you use kubectl. Now, different people call this different things. I'm sure we could take a poll and come up with a few that I haven't even heard yet. Some people call it kubecontrol. Some people call it kubectl. Some people call it kubectl. Some people call it kubectl. Whatever you call it, it's just the command line interface, which means you sit there and you tell Kubernetes, this is what I would like. Please make it happen. All right, so go ahead and insert your favorite Captain Picard reference here. It works. Now there's a set of typical abstractions that we use in that environment as well. There's pod, there's service, there's volume, there's namespace. Pod's just a fancy way of saying one or sometimes more containers. And along with that, we're going to get some storage, we're going to get some unique IPs. At the end of the day, that's our sort of lowest level of deployment. You can think of it, if you want, as an instance of an application. Now, most people, when they say Kubernetes, when they say I'm deploying a container, they mean Docker, but it doesn't have to be a Docker container. It could be others. And while it is very common for there to be just one container in a pod, it is possible for you to have multiples, because you sit there and go, you know what, these two containers are actually really tightly coupled. I would like them to be deployed together so that they can share resources. Right? That's a fairly common pattern. These helper containers are usually referred to as a sidecar. Now, at this point, everybody has a public K8s option. There's Kubernetes engine, there's EKS, there's Fargate, there's Kubernetes on Azure, there's PKS. There's no shortage of options here. Now, the challenge that a lot of people seem to run into, at least the ones I talk to, is it's fairly straightforward to get this up. It's a little harder to do the care and feeding part. It is not as simple as some people want to pretend it is. But it gives us another set of primitives that we can work with. Now, on top of that, we could build an application platform. All right, so this is just another set of abstractions on top of IaaS that leverages containers typically. And so the goal of an app platform is to say, you know what, you just focus on writing your application. You focus on your data. Don't worry about the runtime. Don't worry about the middleware. And the concepts are similar across the various options. I'm most familiar with Cloud Foundry. The general gist is you have Bosch set up a pool of VMs. There's a cloud controller that comes along and says, all right, I'm going to manage these VMs or manage the apps that are running on these VMs. There's a router that sits in front of that says, I know where things live. And so I know how to direct traffic to that specific instance that you happen to deploy. And you as a developer just write an application. The runtime comes from the platform. So if you think about the olden days where we had to move code from one instance of an app server to another, and fingers crossed, sure hope it works. You know, we run into that wonderful worked in dev, not in test. Again, I've torn out a lot of hair over this particular issue. Or again, table flip. He told you I like that slide, right? So instead of moving the code and hoping it all works, we actually just say, no, what? No, this is the same thing. In fact, we don't necessarily even move it at all. We just update the routing table to say, hey, now dev points here, now test points there. So we've moved up the abstraction tree. It's a coarser-grained thing. So now, if we sit here and we say, hey, it worked in test or it worked in QA or whatever it happens to be, we know it's going to work in the next region because it's the exact same thing. In fact, in most situations, nothing has changed, nothing has moved. It's not a new thing on a new instance and a new piece of hardware. We've just updated a routing table. A whole class of errors just goes away. And I like eliminating variables wherever humanly possible. So that actually gives us a level of consistency. And if we think back to the ubiquitous 12-factor apps, we know that one of the 12 factors says, I want parity between dev and prod. I want consistency. Imagine that. What we're fundamentally striving for, and the thing that becomes very clear the more you work with your customers, is we really need to shorten this code to prod cycle. That's a really interesting sort of thought experiment. How long would it take in your existing environment to go from customer wants a change to that change is available in production? And to make it even more fun, imagine it's a really simple change, like I'm going from this shade of purple to that shade of purple on this page. So we're not making a coding change, we're just changing the color. How long would that take? You know, in a lot of the environments I've worked in, that would be measured in weeks at best, even just a simple CSS update. And so anything we can do to shorten that cycle down is a huge win for us because let's be honest, disruption is affecting all of us. There's no industry that's immune from this. Even industries that we've traditionally thought of as, oh no, no one's going to bust into that. And then you realize, wait, who did Amazon just buy? They just bought Whole Foods? Oh gosh, what does that mean for grocery stores? You know, it fundamentally changes how we look at some of these things. Now, it's a good question to ask, you know, hey, where does my runtime come from in this environment? And in this case, it's coming from a build pack. So you push an app, and CF looks at it and says, oh, okay, I know what kind of app that is. And then it goes ahead, gets the proper build pack, and deploys your app into that build pack, uploads it. Router says, okay, I got room on this guy, plunks it out on that server, and away you go. The beauty of that is you don't have to know everything that goes into it. So I run my personal blog on it's a Hugo-generated site, it's a static website, it runs on Heroku, I run it on PWS. I don't know how to set up Nginx. I've never done that before. I'm sure I could, but I don't have to, because I just do CF push my little website, and it recognizes, oh, this is static, and it goes and grabs me the latest version of Nginx and deploys it. It's magic. I remember the very first time I deployed a .NET app. I don't know that much about .NET, but I went ahead, CF push, it recognized it's .NET, and the rest is history. And so you've got everything you need right there inside that droplet. It's less for me to worry about, less for me to deal with, less for me to manage, and it fundamentally moves the value line. And that's an important thing for us to understand. How do we provide value in our organizations? What is it that we want to do? What is it our customers want us to do? And where am I spending my time? Where would I rather spend my time? And so this environment tries to get us out of this world of what we refer to as undifferentiated heavy lifting. Right? And this can be summed up in this somewhat infamous haiku, at least in our world, CF push, here's my source code, run it on the cloud for me, I do not care how. I mean, that's really what we're trying to get to. I don't want to know the specifics of this, just make it work. Now, part of where this becomes so advantageous for us is, multiple times in my career, I've wanted to be on a different version of Java than some other application in my company, and the answer is always no. Because our app servers are at this level, and we can't move because we have this one heritage application that just has to have that old version of Java, so I'm sorry, you're stuck until everybody moves. That's really frustrating. You're always sort of constrained by that oldest, worst, least common denominator thing, as opposed to being able to say, but I need to be on, or I want to take advantage of this feature. Now, it's of course possible to customize these. There's nothing wrong. There's nothing that says you can't customize a build pack. You should always have a little bit of pause whenever you do that. And so the right answer to this question, actually if I take a step back, there's 3 answers that work for every question you've ever been asked in computer science. And I'm sure you've heard me say this, Jack. 42, that's to see who's, actually I saw somebody either today or yesterday wearing a shirt that said 42 and I'm like, ha, well played. That's a reference to Hitchhiker's Guide for those of you that didn't understand the chuckles. As an architect as a service, my favorite of course is another layer of indirection. But the answer that I reach for more often than anything, quite frankly, is it depends. Now, a lot of people get mad at me when I say it depends because they think that's the end of the conversation, and I never intended that way. It is the beginning of the conversation. And by the way, when someone says to you it depends, the next question out of your mouth should be, what does it depend on? And then we start having that conversation. So yes, absolutely, there are instances where I should customize a build pack. I've seen that in environments where it's like, we need some specific things or we need to support this particular thing and the easiest way to do that is to make a custom build pack for it. But you should always take a step back and ask yourself, is this really the right thing to do? Because anytime I customize anything, I'm now signing up for a long-term care agreement. You build it, you own it. And so we should be asking ourselves, do I want to maintain this for the next 3 to 5 years? Because again, make sure you stay current. And ask yourself, how will you fix things like Meltdown Inspector and other nefarious things that will happen inevitably in the next 2 to 5 years? The point of using this level of abstraction is to get you away from some of that undifferentiated heavy lifting. And so again, I ask yourself, what do your customers want you to do? What do you want to focus on? Do they care about the runtime? Do any of your customers know what version of likely Linux you're running on? Do they care what version of Java you're running? I hope not. To them that's a dial tone. That should be something that doesn't even come up in conversations. One of the things that I've discovered in my career is nobody bakes us a cake because we moved the operating system from version X to version X+1. They don't care about that. They want features. They want this thing added to their application that they've been asking for 2.5 years. So the goal of a platform is to say, free yourself up from that. Don't worry about the underlying operating system-y kind of issues. Don't worry about the plumbing. Worry about solving business problems. Now there's a lot of different options here, Cloud Foundry, Heroku, et cetera. But that's kind of that next level of abstraction. Now, of course, over the last couple of years, everybody and their cousin gets very excited about serverless. I actually had somebody come up to me a couple months ago and said, we're going to refactor our entire application as a set of functions. I had to bite my tongue to keep from chuckling. It's like, that's probably not a good idea. Now you recognize pretty quickly that, life moves pretty fast. We go from IaaS to CaaS to PaaS. Now we've got serverless or FaaS. And of course the irony of serverless is there are still servers. It's like kind of not the best name I guess we've ever come up with. The beauty of this is we are just further abstracted away from them. In this environment, I'm not responsible at all for the servers. I'm not there to provision it. I'm not there to update it. I'm not responsible for scaling it. It's someone else's problem. And it's important to understand that there's a lot of moving parts here. And so Sam tweeted this out and he was putting this slide together and he kind of talks about all these layers and essentially says, wait, haven't we made things worse? All of these things need to be patched now. All of these things are things that I'm responsible for. Is that really better? Or have we just made things significantly worse than they were before? Now that prompted a reply from Josh, and he said, well, you're right, but that's why we have platforms like Cloud Foundry. That's why we have the public cloud providers to abstract us away from that so that you can just focus on your app, not on all these moving parts. Let someone else deal with that. So it's, I think, important again to kind of understand how these pieces build on top of one another and how they differentiate from one another. So we always have IaaS as part of this equation. That still doesn't go away. There's still physical hardware somewhere, whether it's on premises, whether it's in somebody else's data center is kind of irrelevant, except when it comes to latency. So we could use containers, in which case our job is to bring the container to the party. And then that container environment is going to give us scheduling and networking and routing and metrics and things like that. I could use a platform, in which case that container gets provided by the platform and my job is to bring an application to the party. And then the platform is responsible for images and networking and monitoring and metrics and marketplaces and quotas and things like that. If I take a step up to serverless, again, that container, you could even argue the application, so to speak, kind of comes along for the ride as well. All I'm responsible for now is a function. This might be 5 or 10 lines of code. And that serverless environment is responsible for executing the function, scaling the function, binding to that event stream, scaling it back down to 0, et cetera. And so the important distinction between all of these fundamentally is, what am I responsible for versus what does the platform give me? That's all we're really talking about here. And so the thing that I want you to understand is every one of these has a purpose. There's a value, there's a reason for using every one of these. The challenge for us is knowing when to use which abstraction. And so at the end of the day, that's all we're talking about here. Now there's another way of viewing this same sort of approach. This is sometimes referred to as the layer cake. You've always got hardware. On top of that, we've built various automation to try to make it faster to procure hardware, to get hardware spun up. We got containers sitting on top of that to make it even easier to get these environments, situated. We got platforms that essentially build on top of that. And then of course now we've got serverless that really lives kind of at the very top of that. And so as I go down that hierarchy, I have much more flexibility. I can do whatever I want at the bottom. If I'm doing pure hardware, my options are limitless. There's also a lot fewer standards. If I go up the hierarchy, I get a lot less complexity, I get a lot more efficiency, there's a lot less for me to worry about, I can focus more on solving business problems. I am constrained somewhat, but fundamentally I get some benefit for that. Now, I would argue it is fundamentally in our best interest to push as many workloads as high up that hierarchy as we can, as is appropriate. I want to emphasize the word appropriate. Again, I've had some people try to tell me my whole application is going to be serverless, and I just don't think that's a good idea for the vast majority of us. Are there aspects of even your current oldest legacy system that would make a great fit for a function, for a serverless environment? Absolutely. The whole application? Probably not. Now, some people would argue this is the new PaaS. There's different debates we can have about that. We love to make up new words in this industry. There are so many different options here. Obviously, Lambda kind of got this party started. There's also Azure Functions, there's Google Cloud Functions, there's Knative, there's Riff, OpenWhisk, Kubeless, Fission, you name it. I will emphasize, serverless functions, this very much suffers from the shiny new thing curse. All right, I used this point earlier today, but as developers, as technologists, we have this tendency to just like chase after the next thing, right? It's like a dog and a squirrel. It's like run after that one, and then someone says blockchain, we all run after that one. Insert your favorite buzzword here. And so we do have to fundamentally realize that that is part of what's happening here, is it's yet another instance of, I would like to get that on my resume, otherwise known as resume-driven design. Seen it a lot. I've practiced it sometimes. And so we have to remember too that we don't just want to be lemmings jumping off the proverbial cliff. It needs to make sense for us. It needs to be the right pick for us in this situation. So I think it's fair to say that FaaS is fundamentally a subset of serverless, although there are more than a few people that do use the terms completely interchangeable. I want to stress there are some really, really good reasons to use this kind of an approach. Now in some cases, it's because we're already on a specific platform. Maybe we've got a bunch of data with a provider, maybe we've got a bunch of stuff sitting on S3, and we want to be able to do something with that. We want to do a little batch processing. Maybe we want to take advantage of a particular service that's offered. Maybe you really want to utilize machine learning on Google. So there are really good reasons just from that sort of a strategic or tactical standpoint. But I want to stress this isn't just a new way to cloud. We actually get some very significant efficiency gains here. Some of it just comes from us as developers. Think about a function. A function is 5, 10, 15 lines of code. How long does it take you to get your head wrapped around 5, 10, 15 lines of code? Contrast that with some of the legacy apps you've probably worked on. I remember one app that I was a part of, I think our getting started guide was like 87 pages long. And it still required multiple steps. I worked at one organization where it took you anywhere from 3 days to 2 weeks to actually get a new build up and running on your machine, which meant that no one actually had a current version of the application front to back. You could stay current within your part of the application, but there's just no possible way to get the entire application up and running. That was painful, to say the least. And so when you're a new developer, it took so long to get you to a point of being productive, it really was painful from both sides of the equation. So functions just push us even further up that abstraction curve and allows us to once again focus on the implementation details, the business problem, not the infrastructure problems. And I always like asking people this. I mean, do you know exactly what operating system your code runs on right now? Do you know which version? Which patch level? Do you care? Should you care? I mean, where do you want to spend your time? Where do your customers want you spending your time? I mean, I really urge you to think about what is the value line for you? What are the kind of things you actually want to do day in, day out? So we're doing everything we can to get out of this business of undifferentiated heavy lifting. We want to focus on business problems. We don't want to focus on these underlying plumbing issues. Now, one of the things that gets people very excited about a serverless environment is the resource efficiencies, because the beauty of a serverless environment is, hey, you know what? No one's called this function in some period of time. Maybe it's a few seconds, maybe it's a minute. We'll get rid of the container. We don't even need it around anymore. Oh, hey, look, a request came in. Go ahead, spring into existence an instance to handle that request. That's very useful. Because, of course, if the container's destroyed, I'm not paying anything. I'm only paying for instances that are invoked. Now, some people seem to equate that with functions being free. They're not. Now, yes, of course, the providers will give you a tier of free requests, typically a couple million, and that sounds like a lot until you actually start using them, and then realize it doesn't take very long to plow through that number of requests. And of course, there's always a little asterisk that goes next to this, which is additional fees may apply. And there's two ways that sort of comes into fruition. One is the fact that data transfer and other services you may use have a fee that's not factored into that. And of course, these fractional costs are really hard to judge because it's this very strange fraction of a penny, and I think a lot of companies will embed part of pi in there somewhere just to be cute. And so it's really hard to understand, like, because it's this really small number. How expensive could this be? We'll get out a spreadsheet and do some modeling and find out. You know, everybody remembers that sort of infamous series apart from Superman, you know, we're gonna shave off the fractions of a penny. You know, it doesn't sound like a lot of money until you add them all up. It doesn't sound like a lot of money until you add in the fact that, oh wait, I gotta pay for the data transfer. I've gotta pay for using the translation service, whatever it happens to be. And of course, my charge, what I'm being charged here is fundamentally based on how many requests did I make, how long did those requests take to actually complete, and how many resources did I allocate for that? And by the way, the maximum resource allocation for any of these functions is usually pretty small. You don't get to have like 20 gigs or anything crazy like that. It's supposed to be small. So it can be very difficult for us to actually figure out what is this going to cost us. And if we're not careful, our CFO comes and has a very unpleasant conversation with us about our cloud bill. Now that said, for certain workloads, this is as cost effective as it gets. We also get some very good operational efficiencies here. Some people refer to this as serverless ops. Again, what it boils down to is there's less for us specifically to worry about. More of this becomes someone else's problems. And so again, we want to rely on a platform to take advantage of that for us. There are a number of use cases that fit very nicely within the functions environment. So when you've got this rapidly evolving business requirement, nobody can really tell you exactly what it needs to do. That works fairly well. Obviously things that are stateless, anything where it's like, I don't really have a good sense of what the request pattern looks like. It's infrequent, or it's sporadic, or it's very variable. This works nicely for asynchronous workloads, anything I can parallelize. You see this an awful lot in the IoT environment, machine learning, batch processing. Works really well for batch processing. You know, you think about a typical batch processing routine, you know, you've got 10 million records to roll through. All of a sudden that cold start doesn't matter at all because I'm gonna do 10 million of them. Almost all the conversational UIs like Alexa and whatnot fit into this bucket as well. I've seen some interesting things here with CI, CD, or chat integration. I saw one company that actually had baked this in. If somebody asked a question on Stack Overflow, it triggered a function that basically sent a poke to somebody on the development team to say, hey, go look at that question and see if you can answer it. You see it for various back-end processing things, post handlers, authentication, monitoring, notifications, alerting, that kind of stuff. You know, think about anything that happens fairly sporadically and I don't necessarily care what the response time is. And so my favorite prototypical example, you go to your favorite website, you update your phone number, your email address, something like that. Some number of seconds or minutes later, you get an email saying, hey, by the way, we just noticed that your account was updated. If that was you, just ignore this email. Otherwise, hey, you should probably call our customer support line. That's the kind of thing that fits very well in this environment, because how often does someone do it? Don't know. Does someone need an immediate response? Not really. As long as it gets there within a few minutes, it's fine. But probably not the right approach for, I have a latency sensitive situation. So it is a very valuable tool. However, it is not the answer for every problem we've ever encountered. So I saw Dave Syer give a presentation about this earlier this year, and I sort of tried to sum up what he was driving at here, and this to me was kind of the aha moment when he said it's all about latency sensitivity. You know, a lot of people like to say, well, you can't use Java in a serverless environment because, you know, cold start hurts too much. That's not relevant. If you're worried about cold start, the problem isn't the language you chose. The problem is the fact that you tried to do it as a function. So you got to take a step back and ask yourself, is this particular use case going to be latency sensitive or not? If it is, it's probably not the right choice. I should find another solution. And I've got other abstractions to pick from. I should choose one of those. Now, again, we know that. That's part of this. And there's a lot of different ways to solve this problem, but many of us are looking for some kind of a, I don't want to say universal, but a more portable approach. And that was sort of the genesis of Riff. And so I like the fact that Riff is one of those recursive acronyms. Riff is for functions. Isn't that nice? You know, Mark can get into specifically where that name came from, but this is essentially FaaS on top of Kubernetes, or these days built on top of Knative. And so like so many of these other environments, the whole goal here is I want to execute a function when an event happens. All right, so as it sits now, this is based on Riff invokers running on top of Knative, and the whole goal is let's focus on the two things that we as developers really care about. The function that I'm actually going to write, what is the business process here, what are the 5, 10, 15 lines of code I'm going to write, and then where's that message coming from? What's that topic channel look like? Now again, these streams might be low frequency, they might be continuous, they might be unpredictable, doesn't necessarily matter, but understand that the sort of genesis of this, the developers that are working on this has come out of things that came out of Spring Cloud Streams, data flow, things like that. The beauty of this environment is it's designed to be polyglot. That's really what many of us are shooting for these days. That's certainly one of the promises of microservices. And so at least as it sits right now, there's a whole bunch of different languages that you can choose from. And the goal here, just like in any other environment, is scale up, scale down as necessary. Now, I think it was a year ago or so, they posited this notion of ICE, which is sort of meant to be like CAP, but for serverless. You know, that when we look at this functions environment, the serverless environment, we basically can have it be immediate, we can have it be consistent, we can have it be efficient, but we can't have it be all three. We basically get to pick two. And so we have to take a step back and ask ourselves, you know, what are we deeply concerned about? What matters the most to us? Is it all about resource utilization? Is it about immutable containers? Because like so many things in our world, it's just a set of compromises. And so what I find interesting is there's a number of people who do a serverless environment and they keep their functions warm. They keep poking them every so often to make sure the container never goes away. And I always think that's a little odd. That seems to kind of defeat the purpose. So if I keep that container running forever, well, I'm paying for resources I'm not actually using. Now, the way some people get around this is they say, all right, well, I'm actually going to have a container around, and I'm just going to inject my code into that container, which means we kind of lose immutability. But of course, if I launch a container when the demand comes in, now I suffer from the cold startup experience that gets everybody concerned. So how do I solve that problem? What do I want to do here? Which of these two do I want? Which one do I have to give up? Now, it's true that a lot of the providers use dynamic loading, but at least one of the early stated goals of Riff was to say, no, you're responsible for that. You get to choose what makes sense for you. Now, one of the things that I've liked about Riff as I played with it over the last, not quite year, is it's very thin, right? And it continues to evolve. So at this point, they're deployed as and run on Knative as services. The CLI builds on top of Knative and kubectl. So these different invokers are just an installable resource that you go ahead and use the ones you want. This is just another way of saying inversion of control. Don't call us, we'll call you. All right, there's a sidecar that actually knows how to bind to the event broker. That's where the proxy pattern comes in. This actually now leverages both Knative's revisions and routes. There is a Riff build pack for Java now. which allows you to create the function from source. So you can just write it right there, as long as there's, I think it's a Maven file that's available, you can just actually build it directly from that. You can also say, hey, here's where my code lives, here's the repository. Go ahead and build that, and then push that image either to Docker Hub or up to GCR. If I rebuild it, I actually can get a new revision built for everyone. That's one of the things that Knative gives us, is now I could actually theoretically have different versions of that function running at the same time if I wanted to. There's now a CLI built around the subscriptions directly, so I can use that to manage those channels. I can create, I can delete, I can list with a bunch of different parameters that go along with that. Now the challenge, especially for me with this, is it's evolving very, very rapidly. It changed quite a bit when Knative was officially announced. But it has the same stated goal, which is we want this agnostic layer on top of FaaS. We want people to be able to run it wherever they want. So the reality for most of us is polycloud. And that could be for tactical reasons, that could be for strategic reasons, but let's be honest, many of us come from an environment where we have an established data center. We're not going to get rid of that anytime soon. We do want to run some things on premises. We also want to take advantage of what we can do in the public cloud providers. We may not want to put all our eggs in one public cloud provider's basket. We may want the flexibility to move things back and forth. We may just want to be able to pick best of breed. We might want to use this feature from AWS and this feature from Google and this feature from Azure. And so we want that flexibility. Now, fundamentally, this is made up of many of the things I've already talked about today. So Knative, I'll go a little bit into this, although there are deeper dives as we go throughout the week here. Google looked at this space and said, God, there's a lot of fragmentation there. And so they came up with a little wordy, but a Kubernetes-based platform to build, deploy, and manage modern serverless workloads. Or if you look at the Riff documentation, Kubernetes native APIs for deploying serverless-style functions, applications, and containers. All right, essentially what this boils down to is a bit of middleware that allows you to run this function anywhere you want, that gives you many of the things you would expect it to give you. Orchestration, routing, traffic management, etc. Scale up, scale down to 0 when there's been no requests. Essentially, it's just yet another agnostic layer over FaaS. This one just happens to be built on top of Kubernetes with a little bit of Istio mixed in. Now there's 3 primary blocks that Knative gives you. There's the build step. And what I really appreciate about this is it's pluggable. So it's not defining this is the one way you do it. It is designed out of the box to be part of a CI/CD pipeline. It supports all sorts of different build methods. So you can use build packs, you can use Docker files, you can use Bazel, Canico, whatever you want. Inside of the build, you've got 4 primary components to that. Where would you say your source code lives? What are the steps? What's the actual template you want me to do to build that container? What's the account that you want me to use to actually execute that build? And then I might need some things available to me as I'm doing the build, and those live in volumes. The second big major building block of Knative is eventing, which is just another way of saying, how do I get pub sub to event streams like Kafka? Doesn't have to be Kafka, but that's what a lot of us are using. And so that's just, as you might guess, an abstraction over the event stream. Now the goal here is to free us as developers from worrying about that underlying message broker, how to set it up, how to scale it. That's somebody else's problem. And so that does leverage the standard Kubernetes custom resources. And so this is referred to as channels, which is just another way of saying topics. And then there's the bus, which is the provider. So Google Cloud Pub Sub, Kafka, RabbitMQ, et cetera. All right, so this is the general model of what that looks like. You publish to the channel knows who's subscribed to it, pushes it to the app, the function, et cetera, and it's responsible for interacting with whatever that underlying message broker happens to be. The third major piece, as you can probably guess, is serving. How do we scale up and scale down? So when it sees lag grows, it says, okay, I'm gonna go ahead and add more workers here, we'll spin up some more pods, we'll get some more resources thrown at this. Okay, now the demand is starting to go away, I'm gonna scale down and eventually go to 0, let all of that go away. The other interesting piece of this is revision control. So Istio's in the middle of this saying, I know how to route traffic, and I can route traffic to different versions of a function. Again, otherwise known as a revision. So I can use this for 0 downtime deploys, for blue-green deploys, et cetera. I've already said Kubernetes multiple times. We've talked about that earlier. We've talked about Docker before. And of course, I've mentioned Kafka a few times. Kafka is just a distributed streaming platform. It's just another message queue. It gives us pub sub. You can argue it's kind of the best of all worlds here. It gives us this real-time stream processing. You push the record out to a topic. The record has a key, a value, and a timestamp. And then Kafka is responsible for partitioning the log of those topics. They're ordered, they're immutable. Everything has an offset so that your consumers can go ahead and pick up where they left off. They can go further, they can go back in time. Everything is retained based on your retention settings. Consumers come and go and do whatever they want. So the beauty of that is you can go back in time if you need to, you can skip ahead, whatever makes sense. So whatever you need to do to support this kind of processing. I recognized at one point in my career, I actually worked on this system where every change had to be audited. Anytime a customer went in and updated anything, we had to record old value, new value. So we had this whole set of audit tables. And it occurs to me now in hindsight that that really was probably an event system. We just hadn't invented it yet. That didn't exist as an option. So in a nutshell, I would argue Kafka is essentially the best of the pub sub and a queue put together. All right, so it gives you that multiple subscription approach, split things across multiple consumers, do what you need to do there. Now, the overarching question that you should be asking is well, which of these various approaches should I use? When should I pick serverless off the shelf? When should I build a full application? When should I use Docker, et cetera? And you all know what I'm going to say next. It depends. All right? I'd love to tell you there's one true answer to this. There is no golden hammer here. I'm sorry. The reality, and the longer I do this, the more I realize this applies in so many situations I've been involved in technology. We have this desire in many situations to have everything be an or answer, and that's not what we want. That's not the right choice. They have to be and answers. You'll use all of these. The difficult part for us is to figure out when should I pull which abstraction. Not every workload fits in every one of these buckets, and our job is to understand and evaluate the trade-offs here. Again, this isn't new and shocking to any of you. I keep going back to this quote because we need to understand that if I pick the super flexible approach, I get a lot of power with that, but I'm also responsible for so much more. I need to understand the implications to the complexity of the environment I'm asking my developers to work in. I need to ask myself, what do I want my developers focusing on? Do I want them thinking about OS patches? Do I want them pushing applications? I need to think about my operational efficiency. I need to ask myself, how many operators does it actually take to manage this bespoke artisanal environment? How many operators would I really like working on that? We have to understand the trade-offs between flexibility and standardization. A lot of us seem to think guardrails are shackles. They're not. They're there to protect us. If you've ever driven on a mountain road and looked over the edge, you're awfully glad there's a guardrail there. I don't know if any of you watched the Tour de France at all, but I remember watching these guys bomb down one of these mountain passes just thinking, boy, you make one wrong decision coming out of a turn and there's nothing stopping you from going several hundred or 1,000 feet down the side of this mountain. Fundamentally, a guardrail is there to protect us. And so we have to ask ourselves, how do we want to allocate our resources? And then take a step back and say, what option fits the problem? Again, these are all tools. So the analogy that I've been using with folks about this is think about hammers. Right? If you go to Home Depot and you go down the hammer aisle, you'll quickly discover there's not just one hammer, there's a whole aisle of them. They're different shapes, different sizes, different weights. Some have a claw on the back of them, some don't. Some have a smooth surface, some don't. Now, I am not a carpenter. I don't know. I'm a software guy. That's a hardware problem. I have one hammer at home because that's more than enough for me to screw up all sorts of problems. Now, we're in the process of finishing our basement. And by we, I mean we have a general contractor who's responsible for finishing our basement. And so when these various tradespeople show up, they don't just bring one tool. And in fact, if a carpenter showed up and he said, this is the one hammer I use for everything, I would politely ask him or her to leave. Because you fundamentally understand that the hammer you use for roofing is not the same hammer you use to tear down a wall, is not the same hammer you use to put that beautiful maple trim along your baseboard. So if a carpenter shows up and I expect them to have more than one hammer, why should I show up and work with a customer and say, oh, I only have one abstraction. All I use is insert abstraction here. That's not the appropriate response from us. They should ask us to leave in that situation as well. So we need to understand that these are all tools, and we need to be able to critically look at these situations and ask ourselves, what is the right fit in this particular situation? Or, as James tweeted, this is what we're looking at here. All of these things are going to be part of this situation. So this is actually from one of Dave's presentations, which I think is actually kind of ironic because I couldn't help but notice that somebody tweeted this out too. Nicole said, hey, I think the whole point of James is to actually tweet out things that we then put into our decks. And she's not wrong. All right, because you notice that both of these tweets were from yesterday, and here they are in the deck today. That's how it works. In general, I would say it's in our best interest to push as many workloads as high up that abstraction hierarchy as we can. But that does not mean everything is going to fit there. We need to ask ourselves about the business case, the use case, what can we do with it from a technology standpoint. Again, I had someone tell me, I'm going to refactor my entire application of functions. Probably not a good idea. Are there aspects of your current system that are a great fit for functions? Totally. Your whole application? I highly doubt it. There might be one or two of those applications in the world. I haven't seen them yet. It's also important to understand this is an evolving space. To say it politely, functions are moving pretty fast. Riff itself is incredibly new. Knative itself is incredibly new. So if you want more on this, there is plenty of material here this week for you to get more in depth on these things. So you can look at some of the presentations that have been done on Riff. You can see the various things that have been done on serverless Spring. I think Dave did a presentation earlier today on Spring and Riff. You can look at some of the older presentations on this as well. And I would just sum this up by saying, good luck. It can be done. The challenge for us is picking the right tool in the right situation. Thanks, everybody. Appreciate your time.